Hi, my dear student. Today we will discuss about the Perkin's condensation. What is this Perkin's condensation and what are the mechanism involved in this Perkin's condensation? Before that, we will discuss the important points and the what are the reagent or the subtract which is required for the Perkin's condensation. We will see in this topic. First, we want for Perkin's condensation we require benzaldehyde. What's the formula? Benzaldehyde C6H5CHO, right? Benzaldehyde. Here is another formula. The same formula I have written like this in structurally benzaldehyde, and what another one reagent is acetic anhydride is required. So what's the formula? CH3COOCOCH3. Right, that is CH3. Okay, so first point is benzaldehyde. We require benzaldehyde, and another one is the acetic anhydride. Formula for acetic anhydride is CH3COOCOCH3, and second one is we required is CH3CO, sodium acetate, and heat is required, condensation, hence heat is required, and water is also required for this. This is what the second point, which is the reagent, that is sodium acetate, CH3COONA, and finally we will get the product is cinnamic acid. Okay, the product we will get is cinnamic acid. So this is what the structural formula for the cinnamic acid. Okay, next is a simple reactions in one way. We can write it as, okay, when benzaldehyde is treated with the acetic anhydride in presence of heat as well as sodium acetate reagent to form cinnamic acid. Okay, these are the 4 points which is required for the Perkin's condensation. One is benzaldehyde and acetic anhydride. Second is sodium acetate, heat is required, water is also required, and third one is the cinnamic acid. So in simple way, reaction can be written as benzaldehyde when it is treated with the acetic anhydride in presence of reagent sodium acetate, and when it is heated or condensed to form the cinnamic acid. Next is the mechanism involved for the Perkin's condensation. That is, first we have to take the benzaldehyde. Okay, benzaldehyde, where it contains the carbon. This carbon contains positive, that is electron deficient. This carbon is electron deficient, and so hence electrophilic substrate acts as an electrophilic substrate where electron is necessary for this carbon. So for this carbon, the acetate ion will give the electron to the hydrogen, contains the carbon. So hence this electron, here this electron, how this electrons comes? So before that we have to see here the acetic anhydride. Acetic anhydride, when it reacts with the sodium acetate, this sodium acetate gives the electron to this hydrogen. Okay, it takes the hydrogen, this acetate ion takes the hydrogen towards it, and the electron will shift to this carbon. Hence here it gets the negative charge. Okay, once again I will explain, where this benzaldehyde contains the positive charge. Okay, where it is this benzaldehyde contains the carbon atom which acts as an electrodeficient. So electron is necessary for this. Hence this acetate ion will give the electron to the hydrogen for this acetic anhydride. Okay, where this acetic anhydride contains the negative charge, carbon ion. where this acetic anion acts as the nucleophile. Now this carbon contains the electron which acts as a nucleophile, will attach to this carbon which contains the positive charges, and the oxygen needs oxygen needs the electron, so it acquires electron from this pi bond, and here it gets the negative charge. Okay, now the product will form in the form of alpha and beta form, alpha carbon atom and beta carbon atom respect to this carbon. Okay, so here next step, for the where this hydrogen is moved is attached to this oxygen, so it get in the form of alcohol, that is OH, and it is written in the form of CH and H. Okay, next when this when this product is condensed or heated, the water will remove, this water gets removed and it forms the double bond, that is alkene. Okay, double bond. Okay, next here once again I will explain, where after the oxygen is one of the more electronegative atom, it required the electron, so it acquires the electron from the this bond, pi bond, and it gets the negative charge. Here it forms alpha and beta product. This alpha and beta product, okay, for this oxygen, where this sodium acetate acquires the hydrogen, right, that hydrogen will move to this oxygen and it forms OH. And when this product is heated, water will remove and it forms the double bond. And when the next step is hydration. When the hydration process takes place, and when that means the addition of the water, then the cleavage of this bond COO and CO, the cleavage of this bond takes place and forms the, here it takes the hydrogen, okay, and here it takes the oxygen. Because oxygen is more electronegative, it gets the hydrogen, and carbon is less electronegative, hence it gets OH ion, OH minus ion. Okay, to form cinnamic acid, how? pH, CH double bond, CH, COOH, cinnamic acid, plus acetic acid, that is CH3COOH. Okay, once again I will explain Perkin's condensation. Okay, Perkin's condensation. For this Perkin's condensation, more important is the what are the substrate and the reagents is required for this Perkin's condensation. First we require benzaldehyde and then acetic anhydride. What's the formula? CH3COO CH3. And next is sodium acetate, and heat is required, water is also required. And third is cinnamic acid. We required is cinnamic acid. We will get a product cinnamic acid. And in simple reaction we can write it as benzaldehyde when it is treated with the acetic anhydride in presence of sodium acetate to form the cinnamic acid. When next we will see the mechanism. When the benzaldehyde is treated with one of the acetic anhydride ion, how we will get this anion? See, this acetic anhydride, when it is treated with a sodium acetate, for this carbon atom it requires a positive charge. It is one of the electron deficient. Okay, so this acetate ion, when it reacts, it takes the hydrogen from this carbon, and this electron will move towards the carbon atom, this carbon atom, and it gets the carbon ion, that is negative charge on the carbon, which acts as nucleophile. When this nucleophile attached to this carbon atom, then this carbon atom will come and attach to this carbon atom which contains the positive charge of the benzaldehyde. Okay, and oxygen is one of it requires electron, so it takes the electron from the pi bond and it forms the negative charge and forms the alpha beta compound, that is product. When this alpha beta intermediate, when it is condensed or when it is here it will get the OH. How? This hydrogen, it takes the this hydrogen will move towards this oxygen, because oxygen is a more electronegative, hence it acquires the hydrogen. The hydrogen will come and contact with this oxygen, and when this product is heated, then water will remove and it forms one of the double bond. Okay, when this product is treated with the hydration, that means of addition of the water, then here cleavage between this carbon atom and the oxygen will take place, where oxygen is more electronegative, hence it will take the hydrogen, where carbon is less electronegative, it takes the hydroxyl ion, OH minus, and it forms the cinnamic acid and acetic acid, cinnamic acid as well as acetic acid, CH3COOH. Cinnamic acid and acetic acid. Okay, I hope everyone understood this topic, Perkin's condensation. If you have any doubts, please comment on the comment box, and if you want any related topics, so please message me in the commented box, so I can explain that topic in the next video. And don't forget to subscribe and like my channel. Thank you.